Welcome, everyone. I'm so glad that you could join us this evening. My name is Kelly Greenlee. I am the Community Outreach Librarian at Prince Memorial Library in Cumberland. Prince Memorial Library serves Cumberland and North Yarmouth, and this evening we're happy to welcome people from Cumberland and North Yarmouth, but also from elsewhere in Maine, and that's the beauty of a virtual program. So we're happy that you could join us this evening. Tonight's presentation is actually, Raj, I'm just noticing, could you stop sharing your screen just briefly?
Yeah.
Thank you. Hi, everyone.
Yeah.
Here I am. I lost my train of thought. We are here this evening as part of we are a complementary, what I like to call a complementary offering of the Camden Conference. The Camden Conference mission is to foster informed discourse on world issues, and their theme this year is India, Rising Ambitions and Challenges at Home. The conference, which is coming up in February, is always engaging. It's very informative. They have a roster of speakers that's chock-a-block full this year for their weekend. And to tell you a little bit more about the conference, I'm going to introduce Pam Barry, who is here, and she's going to say a few words.
Thank you, Kelly. And I'd like to welcome everyone and thank you for being here this evening. I am a member of the Camden Conference Southern Maine Initiative Committee. And on behalf of the conference, I again would like to welcome you. This is the 37th annual Camden Conference. And as Kelly has pointed out, it's entitled India, Rising Ambitions and Challenges at Home. The conference will be produced live in Camden on February 16th through the 18th at the Opera House in Camden. David Brancaccio, host of NPR's Marketplace, will be the moderator. There are 2 live streaming venues on the big screen in Portland at USM and in Rockland at the Strand Theater. This conference will explore India's growing role as a world power and what that could mean for us here in Maine and the United States and the world. I urge you to visit camdenconference.org for details on the conference and other community events around the state. I would particularly like to thank Kelly and the Prince Memorial Library for their work. They have been extremely cooperative and working very hard to make sure that we can reach people who can be here for these events and then will attend the conference. Now I'll turn it back to Kelly so she can introduce our speaker. Thank you.
Thank you, Pam. Let's see, I'm going to do this. There we go. So millions of people in India are vulnerable to climate change. In 2023, contrary to what we seem to experience this summer in Maine, India saw a significant annual rainfall deficit. For a country whose major crops are rain dependent and that depend on monsoons for farmers to practice agriculture, these are dire circumstances. Add to that projections that indicate that Indian heat waves could cross the survivability limit in as early as 2050, and several parts of South Mumbai are predicted to sink into the Arabian Sea also by 2050. All this is to say that tonight's conversation is extremely important. I'm very thankful that you're here. And I'm also thankful to our speaker tonight, who is here to share his knowledge. It's my pleasure to introduce our speaker. He is Dr. Raj Saha. He is a research manager at the New York Times and a lecturer in data science and AI at the Root Institute at Northeastern University. He is passionate about the democratization of data and technology and how they could be thoughtfully utilized toward building sustainable solutions. Thanks for being with us tonight, Raj.
Thank you, Kelly. Thank you, Pam, for inviting me. Thank you, everyone else, for being here. So let me
I'm sorry,
quickly
Raj,
share my screen.
Raj, can I interrupt for just a moment? I
Go
apologize,
ahead.
everyone, and I apologize for interrupting. But in fact, it sort of sets the stage because I promised Raj that I would ask people if you have questions throughout the evening tonight or throughout the presentation. Raj is very okay with people interrupting. As you can see, he was very polite to me when I just interrupted. You're welcome to either raise your hand in the chat and I'll try and pay attention to that, or you can just, voice in as I did and ask a question along the way. Thanks. Sorry. Go ahead,
Yeah,
Raj.
thanks, Kelly. I actually really like interruptions because that means that the conversation is happening rather than wait for all the questions at the end. So yeah, if you have any questions, feel free to stop me. I'm happy to slow down. But here's what I'll do. I'll start by giving you a little bit context about my background, just to help understand like what exactly I will be focusing on. So my PhD was in climate change as a topic, but really broadly it was about mathematical modeling and dynamical systems. And since my PhD, my postdoctoral work and teaching work at universities and colleges, I've worked on a few different, seemingly very different kinds of projects. So I started working on early climate of Earth, modeling that, understanding why some climate change events happened the way they did. I worked on modeling the Indian summer monsoon. There are these cyclic patterns that happen during the summer monsoons every 2 weeks. There's some spikes in rainfall, understanding reasons behind that. Then on seemingly different areas, I also worked on outbreaks of smallpox historically. Then I left academia sometime during the pandemic, as many people were doing. And then I started working for a startup, a carbon removal startup. And I've also done some work in biology, and currently I work at the New York Times, as Kelly mentioned. So all of these different kinds of work that I have done, they seem very different on the surface, but really they're all about finding some core ways in which systems operate, complex systems operate. And climate is one such system. Human beings are also complex systems. So that's more or less the background. So the approach that I'll take in today's topic is a systems view of what climate change is, how it manifests globally, and how the Indian subcontinent, South Asia as a whole, really acts as a, can't really say microcosm, maybe a macrocosm of all the global changes that you can expect to happen in the next 50, 100 years. Why, I mean, in the next 10 years, that can happen globally due to climate change. We can see them all happening in South Asia and very soon and with great intensity. So I think it is important to also understand systemically how those changes might be manifested, what exactly we can expect and why that is the case. So that will be mainly my focus. I will say that I am not an expert in climate policy. I can give you a systems view of what policy changes need to be, what kind of policy changes we should not be following, what kind of paths we should not be following. But I'll try and steer away from specifics of climate policy because that's not my area of expertise. So here's a brief outline of what I'll talk about. First, a bit of theory, a bit of climate change theory, and then we'll focus on climate change in South Asia, what the challenges are, what some of the historical trends have been, and then in that context, try and understand what opportunities it presents us and how we ought to be thinking about solving, quote unquote, solving these problems as we step into the next few decades. And I say quote unquote solving because I sometimes hate to call the situations that are arising, the emergent situations due to climate change, as problems necessarily, because while they represent difficulties, difficult situations, they also represent opportunities. So it's important for us to be able to see it in that dual light. So if I call it problems, I'll supplant problems plus opportunities in place. Okay, are there any questions so far? Anyone has any questions so far about what I talked about? If not, I'll move forward.
I don't see any raised hands.
Okay, great. So starting with a little bit of history, let's say you could take a camera and go back in time. All thought experiment, right? You go back in time, you place a camera somewhere in the Earth's orbit, geostationary orbit, and let it take a picture of the Earth, one picture every, let's say, I don't know, 10,000 years. And of course, you're an alien species. And then after 4 billion years or so, you make a movie out of all those pictures, and then you see what the Earth has gone through. And if you could do that, you'll see that very early on in Earth's history, it was basically oscillating back and forth between being completely covered in ice or having completely no ice. That was in the very beginning. So the Earth was going back and forth between these two very extreme climate states, what we call climate states. One was the ice house state, and the other is what we call the hot house state. Picture on the left, that's the Earth covered mostly by ice. And that actually did happen. We have very good geological evidence that actually took place. The whole Earth was covered with ice. And then in geological blink of an eye, the ice house state would have transformed into a hot house state where all the ice would melt and it'll all go away and there'll be no ice left anywhere and it'll be hot all over. And it flipped back and forth a few times over the course of a couple of billion years. And if we try to see like why that happened, that we can actually look at these climate states as states that are self-preserving in some ways. So when the Earth is completely covered in ice, it's reflective, right? So because it's reflective, it tends to stay cool. It reflects back a lot of the solar radiation that hits the Earth, and that helps it stay cool. And on the other hand, when the ice is all gone, the surface is much darker, as you can see. These are cartoon pictures, by the way, hand-drawn cartoon pictures. So when all the ice is gone, then the Earth is much darker, and darker surfaces, we know, they absorb more heat, and that helps it stay warm and stay hot. So we can conceptualize both as cartoonish pictures and actually objectively, mathematically, we can think of these states as being self-sustaining. So once the climate state is all ice, it tends to stay that way. Once it's all hot and no ice, it tends to stay that way. And that we can kind of encapsulate by this, what's called a double well picture. This is often used in physics. So if you think of this as a well, you have valleys and hills. So there's two valleys and there's one hill in the middle, and there's this little ball that's resting at a low point, right? So let's say the Earth is in this ice house state where it's all covered by ice. And then a lot of volcanism goes on. You turn on the volcanoes and they start pumping CO2 into the atmosphere. And once that starts happening, the CO2 starts blanketing the atmosphere and it starts trapping more and more heat. And as it does so, the shape of this potential well changes, and it changes in this particular manner. There's an animation that'll load over here. It'll play again in case you didn't follow the first time around. Just focus on the picture on the left. So just the action of adding more CO2 to the atmosphere makes that icehouse state less and less stable. It lifts it up, and then the ball, which is the Earth, has nowhere else to go. It can only go to the hothouse state. And this change that happens between the ice house and a hothouse state happens rather abruptly. So at first, now if you focus on the picture on the right, that's the graph that follows the temperature. At first, the temperature change is very small, small changes with small additions of CO2, but then past a certain critical point, it's called a tipping point, there's an enormous change. And that change is by and large irreversible. We know this, we can model this mathematically. This is a very simple picture. It just takes really one equation, if you ask me, just one equation to model this behavior. Even though the Earth is really big and complicated, but it really encapsulates what went on over hundreds of millions of years early on in Earth's history. But if you look at the larger span of Earth's history, all up to the present age, we'll see that there's actually four states. You have those ice house and hothouse states on two extremes, and in between, we actually have intermediate states of glaciation. So you see, if you go from the left all the way to the right, there's a gradient in how much ice there is. The ice house state, it's all covered by ice. Then you have a glacial state where a big portion of North America is covered by ice. A lot of the North Atlantic is covered by ice, and this is what it was. This is the state that we were in, say, 20,000 years ago. So Maine, most of Maine would have been under 2-3 kilometers of ice just 20,000 years ago, and that's what the world may have looked like back then. Right now, we are in this state that's called an interglacial state. So it's in between glacial states. And that's when most of the ice is there only on Greenland and on Antarctica. And the rest there's almost no ice. Then historically, we know there's also the hothouse state where there's no ice at all anyway. It's completely, Greenland is completely bare. Antarctica is completely bare. You know, seasonal snow, but that's about it. No permanent ice. So these are all of the climate states. Now you might ask, why is it that the early Earth had these two extreme states, and then more recently we've had the emergence of these two intermediate states? The answer is probably because of the emergence of a complex biosphere, i.e. organisms, plankton in the ocean, plants on land, and complex ecosystem developing. These have interacted with the environment to actually make the environment more favorable for them. Because as you can imagine, neither the hothouse or the icehouse states are very favorable for life. But there was life in both of those states. But because of the evolution of complexity, because of the emergent complex behaviors in ecosystems, it's almost like the biosphere made a groove in the middle and made itself two more favorable states. And those are the glacial and interglacial states. And we can really just talk about this forever. And I don't really want to do that. But the point I want to make over here is that the intermediate states, the not so extreme climate states, are probably very likely due to the emergence of a complex biosphere. And what makes a complex biosphere is really the biodiversity, as in how many species there are, how they're interacting, and how much energy is being exchanged and transferred through this complex hierarchy of organisms. So that's where we are currently. We are in this interglacial state right now. 20,000 years ago, we would have been in this glacial state. And what we risk moving forward because of climate change is a picture like this. I will click on this and this will start an animation. What we risk is that interglacial state becoming less stable and making its way where the barrier goes away between the interglacial and the hothouse climate state, and Earth has nowhere else to go but very quickly transition over to a hothouse state where there's no ice. And you might know that if we melt all the ice that's currently on Greenland, that's currently on Antarctica, we will raise global sea levels by several meters, up to 100 meters. And that will basically mean most of what we know of the coastline of the world today is going to disappear. It's going to go underwater. That's a first risk among a cascading list of risks that entails. Let me quickly pause over here and see if there's questions at this moment.
So Raj, I'm actually curious because you talk about how the ice house and the hot house went back and forth for a number of years.
Yeah.
And you explained how it is we get from ice house to hot house, but how do you get from hot house to ice house?
Yeah, okay. Super interesting question. So there's many different ways in which that can happen, many ways. One way historically that's happened has been actually plankton in the ocean. Plankton in the ocean in a hothouse state. So like let me go back to this picture. Some geological epoch, I forget the name. There was so much plankton in the ocean, they started sucking up a lot of CO2 that was in the atmosphere. And over the course of 100 million years or so, they took down the CO2 level beyond a critical point, so much so that the reverse transition happened. So, I had this picture where the ball was moving from the left well to the right well. Now the opposite thing happened. Now then the CO2 concentration went down, and then the ball was moved from the left to the right. And that kind of transition happened a few times. One time at least because of plankton, emergence of photosynthesis rather. And a few other times may have happened due to increase in volcanism and decrease in volcanism. Sometimes it's happened because of weathering. Some rocks were exposed due to continental plates or hitting each other and raising mountains, and these exposed mountains would have reacted with rainwater. Rainwater would have had CO2 in it, and that would be a slow process of taking out CO2 from the atmosphere. So there are various geological processes that can move the state from one point to the other, from one state to the other.
Thank you. I don't see any other questions in the.
Great. So I'm going to play this animation again, and I'd like you all to take a look at the shape of this well as the transition is taking place from, say, one state to the next state. So I just took some snapshots out of there and I'm putting it down over here. You may have noticed that as the transition was happening, the well got wider, right? And what does this actually mean? What this means is that at any given point in time, the climate state is not exactly stationary. It's not staying still. There's weather. There's a lot of fluctuations that's happening. Maybe a way to think about this is consider this to be an actual three-dimensional object with a bump in the middle, one with a steep bump, rather a steep valley, another with a shallow valley, and you have a little marble in both of these places, and then you start shaking them. You shake them at about the same rate. And what you might see is that in the valley where it's a stable climate state, a deep valley, the marble is not going to wiggle about too much. It won't have too much room. The walls are closing in. It's a stable state. The climate or the weather is not going to vary too much. But as soon as a state transition starts happening, the walls get wider, the valley becomes shallower, and this is what makes, if you were to give this system a little bit of a shake, and there's always shakes, it will move about quite a bit more wildly. So this is probably the most simple way to explain why it is that during this phase of climate transition from one state to another state, why is it that we see extreme weather events? That's because our climate state is actually becoming less stable. It is becoming more like this shallow valley. And the shallow valley means that you can now have extremes that are somewhat paradoxical, meaning even though the world as a whole is warming, you might actually end up getting swings all the way to the left because the climate state is actually weaker as a whole. So you might get extreme cold weather in some places. Take the polar vortex, for example. That's been almost a regular feature now since 2014s. It's happening every year or every other year now. That is because of the instability of the jet stream. And that instability is fundamentally because of a reason like this. So I remember when the polar vortex first happened, a lot of politicians in the US, they were like, ha, see, it's not global warming. There's snow on the ground, or something like that. But really, it's paradoxical because of this reason. The climate state as a whole is becoming more and more unstable, and this instability is producing this extreme chances of extreme weather events. So you can have hurricanes with a lot of energy, cold weather spells, also extreme warm weather spells, which are happening more, droughts, flooding, higher frequencies of all of these extreme weather events. So that is really what we expect, how we expect the climate to behave like while the climate state is moving from our interglacial state to the hothouse state. And that could last anytime, say 10 years, 100 years. We don't really know. So that's what we expect. We don't actually expect that in the next 10, 20, 50 years, there's just not going to be any more ice and we'll have a hothouse Earth. That is unlikely. What is much more likely is that we're going to see more and more extreme weather events. So it's important to keep this in mind as we think about how climate change is actually going to manifest. It is because of this instability in the climate state. Here's a picture. This is actually from my PhD work of climate in the North Atlantic during the last 100,000 years. And here we see this is all analyzed from ice cores in Greenland, and what we see are periods of very abrupt warming. So you can have some cool periods followed by very abrupt warming, followed by slower, more gradual cooling. And this abrupt warming is really a manifestation of a change like what we saw over here, where there's some tipping point that's being passed, and that passing of a tipping point causes a very large abrupt change in the climate, local or global. So it's not just theory. We have very good evidence that that's how climate change actually takes place. I think this is the last theory slide, and then we'll move over to South Asia. So it's also important to keep in mind that climate change is probably just one pie of all the changes that are taking place. And most of these changes are taking place due to human activity. So the folks at the Stockholm Resilience Institute, led by Johan Rockström, they have been doing this pioneering work trying to establish what are called planetary boundaries in several different areas, like climate change, ozone depletion, chemical pollution, land use, freshwater use, biodiversity counts, nutrient flows, pollution, ocean acidification, and so on. And the way they've tried to quantify this is by saying, what is the current rate at which these changes are taking place? And what is the Earth's natural regenerative capacity to be able to counter those changes? And so they made this picture where the green dotted line tells you that if the changes, if the human changes are sitting below the green dotted line, then we are in the region of we're kind of in a safe operating zone because the Earth's regenerative capacity can mitigate those changes to some extent. So we'll see that there's 3 areas over here, 3 pies where we have we have gone beyond the green line. We have offshooted, and one of them is climate change. But biodiversity loss is really the one that we're seeing the most. And you can say it's biodiversity loss is related to climate change, and climate change is related to biodiversity loss. It really doesn't matter to draw any kind of causal connection. But the fact that biodiversity loss is happening at such an alarming rate. In fact, we're probably in the midst of the 6th mass extinction. We're watching it happen. That is something that we should be really, really worried about, because that means that if the complexity of our ecosystems, global ecosystem, the biosphere goes down, that ultimately has a huge effect on the stability of the climate and the environment. So something we should be really, really worried about. I know I'm not painting very much of a happy picture, but that's the story here. It's not really a very happy story, but maybe a story of opportunity. Okay, other questions?
I don't see any questions. I'm particularly interested in your take on that word opportunity. So I'm eager to hear where this is
Yeah,
where this is going. But I don't see any questions in the chat.
Great.
Thanks.
So we can talk a lot about South Asia. This is the picture you see on the right is a picture of I grew up in Calcutta, and this is the local newspaper there. And I remember in 1997, on the 50th anniversary of India's independence, they did a reprint of the paper from 50 years ago. And I particularly remember the subtitle over here in this on the front page, which is "Political Freedom for 1/5 of Human Race." And that, to me, at that point was a shock that, wow, for 300 years or so, 1/5 of human race was living under colonialism. So, well, we're no longer living in colonialism, good. But if you look at the salient features of South Asia, I only listed 3 as might be relevant to this talk. 25% of all humans live in South Asia as of 2023. So 1 in every 4 humans, no longer 1/5. 1 in every 4 humans approximately live in South Asia. 25%. However, in terms of their energy use, the total energy use, only take up 0.2% of the energy use as of 2022. And the last point that I'll make over here is, and these are very high level points, trying to encapsulate a lot of little things. All the climate challenges that we see that might be happening in South Asia mirror all the problems that we're going to be encountering globally, that we are currently encountering, or that we will be in the coming years. So what are some of these challenges? Well, particularly for South Asia, it has the highest density of humans in the world. Bangladesh particularly has is the country with the highest density. India is not too far off. So if you look at this picture, you'll see all of South Asia is in the darkest purple. And that by itself means that if there's any kind of extreme weather event, if there's any drought, any climate-related incident directly, that automatically, just by virtue of the high density that we have there, that automatically affects millions of people, tens of millions of people. So that in itself encapsulates a whole host of problems, cascading host of problems. There's been a great amount of water shortage happening in India, particularly groundwater shortage, because of fluctuations in rainfall farmers have had to rely more and more on the groundwater supply, and in many parts of the country, the aquifer levels are now below sustainable levels, meaning they're not being replenished by rainfall. And in a matter of a few years, a lot of the aquifers are just going to be dry. As far as I know, there's really no conceivable solution being even put forward as to how the country as a whole is going to deal with this very inevitable problem that's coming up in the near future. And currently, right now, a quarter of India is facing a drought, with only 2 states that are unaffected and states that are historically just very dry anyway. We have extreme weather. We talked a little bit about extreme weather, as why they can happen, but recently you might be aware that there were floods in Pakistan, and these floods displaced tens of millions of people, made billions of dollars worth of damage, just uprooted entire villages and communities completely. And people are still reeling from that. At first, you have the actual flood that displaces people, and then you have secondary waves of associated problems, people dying of waterborne illnesses, malnutrition, conflicts, all of those things. They all become tied together and they cascade one after the other. Sea level rise. Bangladesh is the lowest lying country in the world. I think probably lower than the Netherlands. And if sea levels continue to rise, a huge portion of Bangladesh is going to be washed away. The delta is actually just going to be washed away. It's not that water levels are going to rise, but as the water levels rise, they're actually going to erode away a large part of the delta, and we're going to lose really pristine areas that are just unique places for biodiversity. The Sundarbans, they're sitting in the southern part of Bangladesh, and they're the home of the Royal Bengal tiger, for example. Many species of plants, animals that are only unique to those regions. We risk losing that entire region due to sea level rise, and not to mention the displacement that it can cause to humans. See, Bangladesh is surrounded by India, more or less, and the only other country it connects with is Myanmar. And currently, Myanmar is not a very stable place politically. So when folks in Bangladesh, they're being displaced because of rising sea levels, as they have been over the last few years, they really have nowhere else to go but to try and cross the border into India. And I don't know how much you all follow the political news in India and the rhetoric that comes out from politicians, but surprisingly, and unfortunately, over the last few years, it's mirrored a lot of the similar sentiments that you hear in US politicians, I'm not going to take names, about migrants, Central American migrants coming to the US. Ironically, in both cases, one of the main drivers just happens to be climate change. In both these cases of migrations of people moving more north. You can also have migrations because of political changes, political instabilities. Take, for example, the Rohingya people in Myanmar who were displaced, and they had to find their way into Bangladesh and into India. The Himalayan glaciers, for example, because of the rapidly warming temperatures and less snowfall every year, these glaciers the loss is speeding up, which means that past a certain point, they're no longer going to be able to feed the rivers. And these rivers in India, the Ganges and the Brahmaputra rivers, they are the lifeline for a lot of the country. So there's a huge looming risk in what happens when the glacier when the supply of meltwater goes down. And last, there's rising energy demand. Well, of course, India, or rather the West, they've exported their way of life through movies, media, and whatnot, and now everybody, rightly so, wants to live like people do in the West, which means they want to have cars. Why not? They want to have air conditions. Why not? And this also means that their energy usage is going up, and will continue to go up. So here are just some of many challenges. I've just tried to list this few because we have limited time. Then I want to show you, look at the time. Maybe I'll show a happy picture of progress that was made. So this is, I'm taking you to this site called Gapminder. It was started by a Swedish doctor turned statistician, Hans Rosling. And here I'll show you data of how the fertility rate, or the babies per woman, that has changed in countries like the US, India, China, and Bangladesh since 1947. And I'm choosing 1947 as a starting point because that's when India gained independence. The size of the bubbles here show you what the population of the country is. The higher up the bubble sits, that's the average number of children a woman has. So in
Raj,
1947, yeah.
I'm sorry, I'm interrupting. I'm not seeing, I have a black screen on that I'm looking at. I'm not looking at anything.
Oh, okay. Hold up. I think that's because I changed. How about now?
Ah, that's better. Thank you.
Okay, awesome. Yeah, thanks for that. Okay, so there's babies per woman and income. So the richer countries are to the right, poorer countries to the left, and countries that are sitting high up, they have the high number of babies per woman. So for example, let's take a look at this Ethiopia. Ethiopia on average in 1947 had 7.3 babies per woman. China had 5.2, which is this. This is probably, is this Bangladesh or India? This is India. India had close to 6 babies per woman. My grandmother gave birth 12 times. That was prior to 1947. So let's see how this picture has changed since 1947. See that China goes up and down a lot. That's the Cultural Revolution taking place in China. But by and large, countries have lowered the number of babies that women are having significantly to the 2 mark. And at the same time, they've been moving more to the right, meaning the income per person has been going up. But look at the change that Bangladesh has made, for example. Bangladesh has, in this time, made tremendous progress. It has, actually, I'll switch off the trails. Bangladesh started up all the way high over there. It's around six babies per woman. And then within just a few decades, it brought it down to just close to 2. And this has meant, how this has happened is because of essentially local community action. The mullahs and the muftis, they really engaged people in villages who were, by the way, not very educated. They encouraged girls to go to school, girls to get educated. They encouraged use of contraceptives and conversations about birth control. And in a culture that is otherwise very, very traditional. So a country like Bangladesh has managed to bring down the fertility rate tremendously in just a matter of a few decades. And that's really a very hopeful story out there. I'm going to switch my.
So essentially, you're saying it's because of the education of women.
Because of the education of women, exactly.
Yeah.
And how would you guess that education of women could be tied to an environmental change? In that, if Bangladesh did not undertake those initiatives, then right now the situation would be so much more dire, right? There would be an environmental catastrophe, much more so than there is now, right? So we have to be able to make these kinds of unintuitive connections between um, you know, environmental change and social change. I guess if you think about it a little bit, they're not actually unintuitive, but that's the kind of change that we would need to be talking about, and not changes that say can be made by technology. And I'll come to that in a minute. Are you able to see my slide? The resilience, happiness, sustainability slide. Are you able to see this?
Yes.
Okay, so I've talked a lot, spent majority of the time talking about problems, right? And unfortunately, will not be able to talk as long about the positives part because that's yet to happen. But here's a framework in which we can think about all of this. We have to have some key features to. We have to be able to rethink our systems, and some of those key ingredients over here are those bubbles on the right. One is resilience, the other is sustainability, and connecting all of those is happiness. So let's go by this one by one. Resilience is essentially redundancy. In fact, that means it's the opposite of efficiency. What it means is that you would want to have distributed resources. You would want to have many ways of doing the same thing so that when one way breaks down because of climate change or political change or any other instability that happens, there are other things that you can bank on. So redundancy, we must have some level of redundancy in our systems, whether we're talking about transportation systems or food distribution systems or monetary financial systems, information systems, all over the board. We need to have some degree of resilience, i.e. redundancy. But at the same time, we can't be too wasteful. We also have to act sustainably. We have to act in a way where we're not taking resources from the environment at a rate that is much faster than the way in which the environment can regenerate. So we have to also strive with efficiency. But there's the real problem, right? Redundancy is the opposite of efficiency. And so we will need to find the right balance in any of the systems that we are rethinking or redoing. But they need to have both of these ingredients to begin with. And the third ingredient of this is happiness. I mean, remember that we are really worried about climate change from this selfish point of view, that we mainly care about how we humans, how we are going to be dealing with this. So ultimately, it's really about our happiness. However, we don't or rarely actually explicitly talk about happiness as a thing that we should be trying to increase. How can we do that? Well, it's hard. You can't define happiness. It's not a thing you can buy, but maybe we can design our systems which increase happiness. And there are some undeniable ways in which we can go about doing that, right? So,
Raj,
yeah.
we have a question in the chat
Okay.
that says, does India have a Department of Environment, and what is their strategic plan? In what time frame does the government plan to switch to renewable energy?
Okay, so India does have its equivalent of the EPA over here. I don't quite recall their name. I also don't know by what year they want to switch over all the way to renewables, but I can tell you this, that the political language, there is talk about switching to renewables, and there is some change happening about switching to renewables, but there's overall no big commitment to making those changes in any reasonable time frame. That's just not been there. And if anything, lately there's been more of a pushback. There's been a lot of articles coming out recently that you can find where globally there's been now a lot of pushback to slowing down the rate of renewable um, incorporation of renewables in the additional energy capacity. But since you brought this up, I do want to mention that, and that ties in very nicely with the next slide, is we have been sort of conditioned to believe that switching everything over to renewables is going to solve the problem, where that discussion really sidesteps the question of how quickly that needs to happen. So let me give you some numbers. In 2022, last year, the net total addition of energy, talk about the US, in the US, the net total addition to energy capacity was about 2%. Only 2% of existing capacity was added. And out of that 2%, 80% was renewables. And this figure, people went really crazy and gaga about it. I said, look, 80% of all new energy capacity went to renewables. But really, the correct relevant number is 80% of 2%. Right? So if you keep that going, let's be optimistic and keep that at 80% of 2%, for every year from now, exponential growth. And if you were to keep that going, it will take us, we will be well beyond any kind of meeting any kind of climate target. So that's one. Time frame is really important. And two, renewables by themselves won't solve any problems, because then we also have to talk about energy use, energy consumption. Because if consumption is exponentially growing, then we also have to exponentially grow our energy capacity, renewable energy capacity, at the same rate to be able to be part with it. And that requires materials, that requires resources, that requires energy also to build. So it's important to keep scaling in question. So I want to outline just some big ways, just so we're not putting our hopes in the wrong buckets. In my view, and also in the view of a lot of researchers, purely technological solutions are not going to come to our aid. So for example, carbon removal. I worked at a carbon removal startup, and it didn't take me very long, and several of my fellow scientists didn't take us very long to understand that this was not really a thing that is going to solve any problem. It will make some people rich, yes. It will not actually solve any problem. It is physically impossible. So you might hear a lot about carbon removal. You might hear a lot of faith and hope being put in these new emerging technologies, right? I mean, after all, Shopify and Microsoft and Meta, they are investing hundreds of millions of dollars in these technologies. Will they ever work? No. 10 years down the line, 20 years down the line, feel free to send me an email and say, hey, you are wrong. I will be so glad to be wrong. But that's something that I can say with certainty, that these technological solutions are not really going to be in the way, just because of physical scaling limitations. We cannot overcome them. The way carbon removal has to work, for example, will have to be many orders of magnitude higher than any other technological growth in human history.
So what role, and this is a question in the chat, what role does adaptation play in planning for climate change?
So adaptation is everything. We have to be able to adapt. We have to be able to adapt and mitigate. So one way of thinking of adaptation is, well, sea levels are rising. How do we adapt? Well, we can go to our friends in Holland and say, hey, you all over there who talk so much about sustainability and all great things, come and help us build us some dikes. And don't charge us money, please. Do it. Put your words where your what is it? Money where your words are, something like that. So along those lines, building partnerships to and really maybe leveraging some of the advantage that a lot of the Western nations have in building adaptation measures. A lot of the adaptation will have to be cultural. Getting people to move, for example, is not easy. And do we actually need to get them to move? At what point do we need to get them to move? Another part about adaptation would be to think about resilience, right? How do we make our food distribution systems be more adaptable and resilient so that a cyclone happens or a hurricane happens and it floods a route, and then now people in a large chunk of a state cannot get any food supply, right? So those are some adaptation measures that we should be thinking about and thinking about holistically, region by region. And there's some work being done by think tanks here and there, but they're really not they're so far from being implemented that it's really even pointless to say what is happening, because the answer is nothing. There's conversations happening, political conversations happening, but on the ground, what are the changes that are actually taking place? That's not really measurable in my view. Going back to this, what won't solve problems? There's been a big hype with AI, artificial intelligence, and things like that, and there's always a conversation and always this notion that artificial intelligence will solve some of our biggest problems. And it couldn't be farther from the truth, because artificial intelligence as we have today is really something akin to a parrot intelligence, where these systems are mimicking human knowledge and behavior. So it's nothing like AI is going to tell us something we already don't know. We know how to deal with adaptation and what steps we should be taking. It's just we don't have the political will or fortitude to be able to go through with it. We won't be able to solve any of these problems with Econ 101 thinking. And the basis of Econ 101 thinking is really that any waste products that are made, any adverse effects that you have by virtue of doing business, those are externalities, and those externalities are free. They go into the environment. So that's your typical Econ 101 thinking. We cannot really be solving problems, mitigating these problems with Econ 101 thinking. We have to be able to think more holistically. So what are the opportunities? Sorry, this is just one slide because there's not much to add there in terms of actual content, but here are some ideas. What we have to do is shift our paradigms in a lot of different areas. We have to think about how resources are distributed from source to the point of consumption. And we have to think about distributed resources. We have to think about localizing these resources so that we're not growing food in one corner of the country and transporting them by truck and train to the other corner, where maybe we all don't need to eat avocados all year through. Maybe we don't need to have our grapes trucked from California. Maybe it's okay for us to not eat grapes part of the year. Or maybe we should think about ways of growing grapes out here in greenhouses using technology. And that brings us to tech. What is the role of tech over here? a lot of the tech that is being developed, that is being utilized, let's say sustainability-ish initiatives, they are not open source. They are owned by companies and they are trying to make a buck. Whether it be through, say, making forecasts of which plots of land are likely to have more yield, or which areas of the country are likely to be hit more by drought, using satellite data and all that. So all of that is currently our proprietary information. Folks are doing it. They're selling it to insurance agents, and those insurance agents, they are monetizing that. What we really need is open source tech where this information is available to people on the ground for free. And it's not really for free. It benefits everyone, but really it should not be hidden as from the public. Because a lot of the research that went into the development of these technologies were built on public money. We have to think about externalities, including externalities in our equations, in our cost functions, when we're doing economics. We can't go about doing things the Econ 101 way. We have to have cross-border cooperation. And this is particularly a difficult topic in South Asia, where India and Pakistan are two nuclear rivals, right? And so cross-border cooperation, be it scientific or be it about information sharing or sharing aid, that becomes particularly complicated. But maybe we should talk about building layers that are apolitical, that will be operating with one another regardless of what is happening on a political scene. Like the two countries could be at war, but the agencies could still be operating without any barriers. We need to be able to think about that. There are groups that try to do that, but they're very scattered and they do not have much power currently. We need new financial models. We can't depend on big tech companies to come in and throw a bunch of money, because ultimately that's for their own good. We need new financial models, and one of those ways is maybe to think about crowdsourcing, raising money for local adaptation, mitigation projects. Yes, we have taxes, but in countries like South Asian countries, the political corruption should really be mentioned. It's I don't want to say it's there everywhere, but it is a thing to consider. We'd be naive stepping into all of this, and when we talk about finances, and not really ignore the fact that there's a lot of corruption taking place and that is built into the system. We have to think about, well, sure, we want to eradicate all of that, but really time is so short. We have to think about ways of going around those systems somehow without, necessarily making people too angry. And the last, maybe we have to think about labor reforms with technology and with information, the evolution of these. What does our labor actually mean? Why is it that the farmer on the field gets to make a lot less money than somebody going to work in an air-conditioned office? And these questions, or rather these inequities, are really connected to how we are going to be thinking about moving forward in adaptation and resilience and creating sustainable systems. So, holistic picture, it is necessarily harder, but that is the only path that we have. Because if we go about trying to solve any of these systems, any of these problems, our Econ 101 mentality, it's just not going to go anywhere. Only some people will get rich. So I think I'll I'm over
So,
time. I'll stop there, see if there's questions.
I do have a question from somebody who says, who wants to know how we can progress if major world powers are recoiling into nationalistic tendencies.
Well, we can hope that it'll be a transient feature of world politics, and that things are going to change back. But other than that, I mean, we can try and educate ourselves and educate those around us and carry on the conversation, do what we can. And that's about all the agency we have.
Hmm.
But you're right in noticing that there is this trend, and that worries me.
And what's the awareness of climate change in India?
So the actual facts, I would say, if you were to ask the average person, what do you know about climate change? They might, by and large, agree that it is happening. And that is because culturally, I would say in India and Pakistan, um, there is more of a faith in institutions. So even if people do not understand the science themselves, they're willing to put faith in what the scientists are saying. So that is there. People by and large will believe that climate change is happening and that it is a problem. They may not be aware of a lot of facts of what is going on where, but I would say that situation is more optimistic, paradoxically, than it is here in the US.
And I have one comment from somebody who says the Green Revolution has largely been born on the developing world. So, so complicated. Maine has lithium reserves recently discovered, and the mining of that is quite controversial. We in the Western world seem to have a double standard.
Yeah, so I'd maybe ask a question back. Are you in favor of mining, whoever raised the question, are you in favor of mining lithium here in Maine?
Yes, in all caps, with an
Yes, in all caps.
exclamation point.
Yeah. Yeah. So I don't know how I would answer that question myself because what I would ask is how much lithium is there anyway? How many additional years of energy capacity is this going to give us? And then going back to this picture of Econ 101 thinking, we'd have to ask what is the environmental cost for digging up that resource? Because ultimately, if those lithium batteries end up in a landfill after a few years, then what have we really done? We have added. So I'm not saying that it's a bad idea. I'm saying we have to be cautious in doing that math, and it's a hard math to do. You have to figure out how much lithium there is, what are the prospects of how much energy usage we can get out of it, kilowatt hours or what's a storage unit, um, for how long, and then what's the ultimate fate of that lithium, and what's the environmental cost. We have to put all of those terms in our equation to be able to see, is it worth it?
Interesting. Well, are there any other questions that people might have? And you're welcome to, if you don't want to put it in the chat and you want to just speak up, you're welcome to just speak up. I don't have to be the only voice in the room, I promise. Well,
Raj, this is V. Sheehan. Thank you for being here. This has been absolutely fascinating. Going back to what you said near the beginning of your talk about how biodiversity is the feature that is so worrisome. Is that biodiversity as a sort of an indicator of how much the climate has changed? Or is that it's not something that is causing climate change, the lack of biodiversity, is it? It's more a warning signal of where we are. Is that correct?
Yeah, so at least in the time frame where we are at, climate change is very provably being driven by human action, very, very provably, and very easily. And that is having this effect on biodiversity. So not just, the parts of human action that putting CO2 in the air, but putting chemicals in the water, putting destruction of habitat, all of those things. They're all leading to biodiversity. So as of now, the biodiversity loss is probably not showing up in having effects on climate in measurable ways, but it will soon enough. So for example, think about the effect that the Amazon rainforest has on global climate. It basically acts as the lungs of the global climate, right? Like it takes up a lot of the CO2 and it puts back oxygen into the air. And that rainforest is being destroyed at an alarming rate, right? So if the Amazon were to go away, it would take us a few years, and then we will be able to measure its effect on the climate and on the biosphere also as a whole. Okay, do religious beliefs in Southeast Asia have positive, negative, or neutral effect on environmental issues? Yeah, this is an interesting question. I'm not much of a religious person or at all, but I would say from having grown up there, the environment is considered sacred, and like in many other old cultures in the world. And there is this inherent respect for the environment that is built into a lot of religious sentiments out there. But it exists in contradiction. It exists in contradiction to the way ordinary people, are actually treating the environment. And I want to be careful about this because, and I don't want to blame those ordinary people for treating the environment simply because they don't have the means to do to do things differently. Yeah, so while there are beliefs one way, the actions are actually by and large contradictory, and that's a conflict that I see that's very stark. Like every time I go to India, I see that as bipolar states existing all in one picture. Yeah. So positive or negative, hard to say what the sum is, but
Well, I'm sorry, did I hear somebody chiming in? No. Okay. Just want to make sure I'm not interrupting somebody. So I'm struck by the it feels a little hopeless to me, and that makes me sad, and I don't know, you talk about the opportunities, but I wonder, with all of these nationalistic tendencies that we talked about, how you would like to think that the major superpowers will step to the plate and they will model their behavior, but I don't see it happening.
yeah.
And
Sorry, go ahead.
no, go ahead. No, go.
Yeah, what I was going to say is I often, anytime I've given talks on climate, what I hear and what I see is this, oh my God, this is hopeless. Well, of course it is hopeless, but it is very important for us to be clear-eyed about that, because what I don't want to do is to paint pictures of false hope, because that is much worse. But in fact, these opportunities, these 5 or 6 or however many, 3 and 3, 6, these 6 points that I have over here, you can add more, take away some. If we can do these meaningfully, then they can actually result in huge positive shifts. So these are actually huge opportunities. It's just that it is hard to talk about them in complete vacuum because we are really talking about them as theoretical constructs, right? There's only been very few places in the world where some of these ideas have been implemented. Take for example the Mondragon Corporation in Spain, in how they organize themselves and how the workers own the means of production. I mean, I don't want to sound like a political nut. I'm not actually, but uh, we have to be able to think in new paradigms and just sort of discard the prevailing view or notion that we have that okay, these certain political systems were bad or they are bad elsewhere in the world and therefore we cannot know. Let's really try and think about what's good, what we can take out that are good elements from all existing political and economic systems and try and put them together. That's what needs to happen. That is really the correct answer. But we have to be really aware of the hopelessness. Otherwise, we're not really telling the correct story.
Right, because it's that hopelessness that's going to drive the change, really.
Well, let's hope. Yes.
Right, right.
What will be much worse is if we just start believing that carbon removal is now going to solve all our problems, right? Because then we're just not going to be taking any action.
Mm. We have another question in the chat that says, what is the role of nonprofits or NGOs in pushing for moving in the right direction?
Yes, so I really believe that nonprofits and NGOs have a tremendous amount of agency in here in doing the right things because they, they are local. They would be local, and if they can work locally to empower, for example, empower women, make sure women are educated, make sure kids are getting fed when they go to school, just things that increase happiness. If we can just focus on that and even not even think about the climate picture, ultimately that is all those little changes are going to add up to really help us in the climate mitigation sense. Isn't the best answer just to use less? Yes. Cultural change. How do we actually start using less? Do we in the West, do we set the example first? Because we have lived that lifestyle of excesses for several decades now, a couple of generations. Should we maybe set that example and then open source that tech to use less to the other countries? Possibly. But what would not be fair is for us to say that no, you all can't have air conditions and washing machines because there's too many of you, and you're going to be adding this many tons of CO2 into the atmosphere. Well, guess what? The West is where they are today because of its history of starting from child labor to all the slavery and all the way to its energy usage, right? So yeah, it is best just to use less. But how? How do we get there?
To use less and the less that you use to make that local.
Yeah,
right?
yeah. So these ideas exist. It's just
Mhm.
that those ideas are not scalable, and they're not being adopted on a mass scale. How do we make that happen? That maybe is a marketing question, right? And a social change question. I don't know, but it's very important that we do.
Yeah. Yep. Well, Raj, this has been fantastic. Thank you so much, and I really appreciate your visuals for this presentation were excellent and much appreciated. They really helped to give us a backdrop for the conversation. Oh, Kimberly would like to know about your backdrop scene.
My backdrop scene?
Yeah,
Oh yeah,
behind
that's
you.
where I'm sitting. That's my spaceport. Oh, actually, so if you're curious, that was an image I made with generative AI. I gave it a prompt to give me a view from what was my prompt? Give me a view from a futuristic spaceport that looks out into a world that looks hopeful, something like that. Hopeful, but with flying transport things.
Interesting.
So yeah.
And
I wanted it to be hopeful and not dystopian.
did you ask for a city scene or is that
I don't
just what
quite
it gave you?
remember. I don't
Yeah.
quite remember. Yeah, this is what it gave me. It gave me a whole bunch, and this is what
Yeah.
I chose.
Yeah, I love it. That's great. Well, thank you. Thank you for being with us tonight. Thank you, Raj. Thank you, everybody, for joining us and for asking some excellent questions. And you've given us a great deal to talk about. Remember that the Camden Conference is coming up in February. So if you're interested in this topic and in other topics involving India and the rising ambitions and the challenges at home, then join us at the Camden Conference in February. Thanks, Raj. Thank you, everybody, for joining us. Have a good evening.
Thank you.